Bismillahirrahmanirrahim. Starting the chapter number 1 of book 1 of chemistry. In this chapter, we'll be discussing some of the basic concepts of chemistry. First of all, starting with the topic atom. As we are starting with the basic concept, we must have an idea that what is an atom. Atom is the smallest particle of an element which can take part in a chemical reaction. यानी जब हम बात करते हैं एक एटम की, तो ये एक एलिमेंट का सबसे स्मॉलेस्ट पार्टिकल है. ये वो स्मॉलेस्ट पार्टिकल है दैट कैन टेक पार्ट इन अ केमिकल रिएक्शन. फॉर एग्जाम्पल, हीलियम, नियॉन, आर्गॉन, some of the noble gases, nitrogen, oxygen, sulfur, etc. These are the examples of some of the atoms. We can say that the atoms of hydrogen, oxygen, nitrogen, fluorine, etc. they do not exist independently. Whereas helium, neon, argon, they are monoatomic gases. We can say that their atom can exist independently. So we can say that an atom may or may not exist independently. यहाँ पर हमारे पास दोनों तरह की examples मौजूद हैं. Oxygen, nitrogen, hydrogen, their atoms do not exist independently, whereas the atoms of helium, neon, argon, they are monoatomic gases and their atoms can exist independently. Now this is the definition of an atom. We must have an idea about the history or how this concept of atom originated. It's a long history. Long time ago, it was thought that the matter is made up of simple, indivisible particles. It was the Greek philosophers who thought that the matter could be divided into smaller and smaller particles to reach a basic unit. And that basic unit cannot be further subdivided. It was thought by the Greek philosophers. Another important name in the history for the concept of atom is Democritus, who called these particles atoms. This word atom was derived from the word atomos. Atomos means indivisible. Indivisible means which cannot be further subdivided. Keep in mind that the idea of the Greek philosophers was not based on the experimental evidences. In the late 17th century, the quantitative study of the composition of pure substances disclosed that a few elements were the components of many different substances. Moving on, in the year 1808, John Dalton, who was an English school teacher, he made an important contribution for the understanding of the concept of atom. He recognized that the law of conservation of mass and the law of definite proportions, they cannot be explained if we do not accept the existence of atoms. So John Dalton recognized that the law of conservation of matter and the law of definite proportions could be explained by the existence of atoms. John Dalton developed the atomic theory. Atomic theory का main point ही ये है that the matter is composed of atoms of different elements which differ in their properties. So moving on further, in the modern researches, an atom is further composed of subatomic particles. As we know that the fundamental particles of an atom are electron, proton, neutron. Along with that, there are 100 fundamental particles. They are thought to exist in an atom, like hypron, neutrino, antineutrino, mesons, positrons, etc. And then J. Berzelius. J. Berzelius determined the atomic masses of the elements. A number of values determined by J. Berzelius were close to the modern values. Along with that, an important work done by J. Berzelius was he developed the system of giving elements a symbol. This was all about the history or the concept of atom. Now talking about the evidence of atom. जब हम बात करते हैं atom की, हम कहते हैं it is the smallest particle of an element. तो ये बात clear है कि atom का size measure करना एक आसान काम नहीं है. As it is a very small in size, so it is impossible to see an atom. But the evidence of atom can be seen. Now how we can get an evidence of atom? An ordinary optical microscope cannot measure the size of an atom. Why? Because an ordinary optical microscope uses light and the wavelength of light is longer. So it cannot be used to detect or to get an evidence of an atom. Therefore what we use is an electron microscope. An electron microscope has beam of electrons instead of the visible light. as the wavelength of electron is much smaller than the visible light, so it can be used for this purpose. X-ray studies have shown that the diameter of an atom is of the order of 2 into 10 raised to the power minus 10 meters. We can also call this 0.2 nanometers, as we know that 1 nanometer is equals to 10 raised to the power minus 9 meters. We can also say that the radius of an atom will be 1 into 10 raised to the power minus 10 meters or 0.1 nanometer. So 0.1 nanometer can be called as the radius of an atom. Along with that, talking about the mass of an atom, the masses of atoms ranges from 10 raised to the power minus 27 to 10 raised to the power minus 25 kilograms. Here is the picture of an electron microscope photograph of graphite. A piece of graphite is shown here. This photograph is taken by an electron microscope and has been magnified about 15 million times. The bright line in this picture are the layers of carbon atom, whereas the dark lines are the spaces between the layers. As we were talking about the atomic masses, they are often expressed in atomic mass unit, abbreviated as AMU. याद रहे that 1 AMU is equals to 1.66 into 10 raised to the power minus 27 kilograms. This value is very important and it should be memorized. अगर हम इसी वैल्यू को kg के बजाय ग्राम में शो करना चाहें, it will be 1.66 into 10 raised to the power minus 24 grams or 1.66 into 10 raised to the power minus 21 milligrams. These are some of the values which must be memorized as they are important from the objective point of view. So from all this we can conclude that the size of an atom is extremely small. We can also get the idea about the size of an atom from this fact that a full stop contains 2 million atoms, whereas a colon has 4 million atoms. This is just to have an idea about the size of an atom. Topic of discussion is a molecule. As we are discussing basic concepts of chapter number 1, so we must have an idea that what is a molecule. The smallest particle of an element or compound which can exist independently is called a molecule. So जब हम बात करते हैं एक molecule की, we say that it is the smallest particle of an element or compound which can exist independently. Molecule can be classified in the different ways depending upon their size, number of the atoms present in them, and the nature of the atoms. For example, classifying the molecules on the basis of size. A molecule can be called as a macromolecule or micromolecule depending upon the size. For example, if we talk about macromolecules that have large number of atoms of different elements in it. For example, chlorophyll, or important example is hemoglobin. We know that hemoglobin is responsible for carrying blood to the various parts of the body. Apart from hemoglobin, cholesterol, proteins, etc., they are all examples of macromolecules. याद रहे that a hemoglobin molecule is merely having 10,000 atoms and it is 68,000 times heavier than hydrogen atom. Very important points to memorize. Now coming to micromolecules. Molecules of smaller size and lower molecular masses are micromolecules. For example, a water molecule, molecule of methane gas, sulfuric acid, etc. They are all example of micromolecules. Now we can also classify molecules on the basis of the nature of atoms present in them. It can be homoatomic molecule or it can be heteroatomic molecule. Homo means same and hetero means different. अगर हम बात करते हैं homoatomic molecule की तो हम कहते हैं these are the molecules which have same type of atoms. For example, a molecule of hydrogen gas has 2 hydrogen atoms. Nitrogen gas has 2 nitrogen atoms. Similarly, chlorine gas fluorine gas, etc., we can see that they have same type of atom present in them. Chlorine has 2 chlorine atoms. Fluorine gas has 2 fluorine atoms. So what about heteroatomic molecules? The molecules which consist of atoms of different elements. For example, a molecule of benzene has carbon and hydrogen in it. A molecule of sulfur dioxide gas has atoms of sulfur and oxygen. Methane, again a heteroatomic molecule. Water, having hydrogen and oxygen atom, they are all examples of heteroatomic molecules. Coming to the molecules on the basis of nature of atoms, molecule consisting of one atom will be a monoatomic molecule. For example, the monatomic gases, that is the noble gases such as helium, neon, argon, krypton, xenon, etc. They are all examples of the monoatomic molecules. These are the noble gases and they are monoatomic gases having only one atom. Diatomic molecule, the molecule consisting of two atoms. For example, hydrogen gas has two hydrogen atoms. HCl gas, one hydrogen atom and one chlorine atom. Carbon monoxide gas, etc. They are all examples of diatomic molecule. Now, if a molecule consists of more than two atoms, it will be called as a polyatomic molecule. For example, ammonia gas. C6H12O6. Glucose is an example of polyatomic molecule having 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. Carbon tetrachloride, CCl4. It is also an example of polyatomic molecule. So on the basis of number of atoms present in a molecule, we can define atomicity. What is atomicity? Atomicity is the number of atoms present in a molecule. For example, अगर हम बात करें sulfuric acid की, H2SO4. What is the atomicity of sulfuric acid? We can see that it has 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atom. 2 plus 1 plus 4, that is 7. So the atomicity of sulfuric acid is 7. Let's have another example. Glucose. What is the atomicity of glucose? 6 plus 12 plus 6, that is 24. What is the atomicity of hemoglobin? Yes, hemoglobin is made up of 10,000 atoms. So its atomicity is 10,000. That was all about molecule.